So some of the function stuff at the very beginning, we're not going to test on the final, like the domain things, stuff like that. It's okay. I mean, part of the course is a pre-calculus review, but since none of you are going on to do more math from here, at least I hope none of you are. If you are, you're in the wrong course. This is a terminal course, as they say. Or you'll have to go back and take other things. You know, domain is important. You want to know what you can and can't use. Like negative dollars doesn't make sense in a lot of problems. But generally, you know you can't take the square root of a negative number. So we're not really going to get too hung up on some of those things. Generally, the exam will cover limits, derivatives, some integration. You should be able to find when things are going up and down, increasing, decreasing. You should be able to find concavity. So I'll repeat, limits, derivatives, increasing and decreasing. So when a function is going up, when it's going down. Concavity, when it's concave up, concave down. Maximum, minimum. What else? With the integration, you should be able to do regular basic integrals. You should be able to do integrals with substitution. You should be able to do integral approximations with rectangles. You should be able to use the integral to find the total of something. You should be able to take derivatives of a bunch of things with the product rule, the quotient rule, the chain rule. That's about it. You can put any continuity on the exam. Again, it's important, but actually many business functions are discontinuous. There's an abrupt choke. So if you look, say, at Amazon prices, one day it's $379, the next day it's $479. There's no smooth transition from one to the other. I think that's about it. At the moment, the exam is 9 questions with subparts. So, as I said, I figure if you really know what you're doing, you'll be out of there in an hour to an hour and a half for most of you. Some of you will sit there for the entire 2 hours and 15 minutes driving yourself and the proctors crazy while you hope that some last answer strikes you from above. But you never know, it might. Okay? Don't be too anxious about this exam. The exam will be in JAFETS 101. Again, JAFETS 101. I will put this on Blackboard, I think tomorrow. Blackboard's misbehaving right now, so I can't get to it to do some stuff. They'll have it fixed in a couple hours. Right now, when I go into Blackboard, it shows me last semester's courses, which either this isn't December, it's May, or they have some work to do. Is this May? It's really cold for May and dark. So I'm going to go with they're wrong. And there you go. All right, so let's do some practice stuff. So I'll put a few problems up for everybody, and then we'll go over them. As I said, I'll make a list of everything for you guys later. Why don't you practice? Warm up with some of those. Say how well everybody remembers their limits. Always know your limits. Okay, let's start going over these. So, look at the first one. So remember, when you get the limit, you're trying to figure out what happens when x gets really close to 3. Just close to 3. A little bit less or a little bit more. So first thing you do is always just plug in 3 and see what happens. So if you plug in 3 out of the top, you get 3 squared minus 25 over 3 minus 5, which is negative 16 over negative 2, which is 8. So nothing special happens. Okay? There's no issues at x equals 3. So if you look at the curve, it basically goes through the point 3 comma. So you don't have a problem at 3. However, you do have a problem at 5. Because here, if you plug in 5, you get 25 minus 25 is 0 on top. 5 minus 5 is 0 on the bottom. So you get 0 over 0, which makes you nervous. But before you decide that you can't take the limit, you see if you can rewrite the problem. So you notice that this factors into x plus 5, x minus 5, over x minus 5. So the problem is right when you get close to 5, you're getting the factor on top is making the 0, and the factor on the bottom is making it 0. Remember, you're doing the limit as x approaches 5. You're not actually at 5. You're at 4.999999, right? 5.001. You're very close to 5, but you're not actually at 5. So that means that these are the same. They're not 0, so you can cancel them. Now when you plug in 5, you get 10. So if you were to graph this, there would be a hole at 5 comma 10. So if you did the graph, right at 5, there'd be no value. But if there were a value, it would be y equals 10. But at 4.9999, you're at right around 10. I don't forget if you're bigger or smaller. It doesn't really matter. You're at 9.999. Okay? Now what about when x goes to infinity? Well, we know that this behaves like x plus 5 anyway, because we just did that. And as you go to infinity, the top power is squared, and the bottom power is just linear. So the top function will affect what's happening much more than the bottom, to the point that the top function will just dominate the whole thing. So if you plugged in 1,000, you'd have 1,000,000 minus 25 over 1,000 minus 5. So the million would be significantly more, have significantly more impact than 1,000. If you put it in 1,000,000, this is 1,000,000,000,000 minus 25 over 1,000,000 minus 5. So it starts to be irrelevant what's going on the bottom. So this is just going to go to infinity. So far, so good. There'll be some limits on the final. And some of them you have to show some work, some of them you don't have to show any work. Okay? Even if you look at it and you go, this is obvious, show a little work so that we don't think you're just cheating. Okay? Protect yourselves. You can determine what's a lot of work and what's not. All right, limit as x approaches 2 minus. Well, 2 minus is a little bit less than 2. When you square a number a little bit less than 2, you get a little bit less than 4. Since that's less than 4, this will be taking the square root of a negative number, so the limit does not exist. Okay? I'm not sure what work you can show on that. However, when x is just a teeny bit bigger than 2, when you square it, you'll get 4. 4 minus 4 is 0, so this will be 0. So then if you wanted to find it exactly 2, you always test whether the left side agrees with the right side. If the left side does not exist, this limit does not exist. This only has a right-hand limit, or a right side limit. It doesn't have a left side limit. So you can't say what the limit is at 2, because at the number you have to squeeze in from both sides. And when you squeeze in from both sides, you only get an answer when you go from the one side, not the other side. Okay. All right, let's look at the next one. So now we look, and the degree of the top is 8x cubed, or it's cubed. The degree of the bottom is also cubed. So these are moving at the same rate. The functions are growing at the same rate. So if you wanted to do the limit as x goes to infinity, you could ignore these terms. The fact that this is added and this is subtracted doesn't mean anything because they're only x. So the only thing you care about is that this behaves like 8x cubed over 4x cubed, which is 2. All right, what about that last one? Well, the last one is saying, let's see, let me show. So I'm doing just approaches a number. You have to check the left hand and the right hand limit. So let's see, the limit when x approaches 8 to the plus side of 9 over x minus 8. That'll give me 9 over 0, which is infinite. The question is it plus infinity or is it minus infinity? Well, since x is just a little bit bigger than 8, this is just bigger than 0, so it's positive. So that's positive infinity. And then if we did the other side, the left-hand limit, now you have a number just smaller than 8, 7.9999. So this will come out negative. So this will be negative infinity. Since these don't agree, the limit does not exist. So remember, when you're doing to a number, if we don't give you a plus or minus, you have to check both sides. Okay? How are we doing these? We loving the limits? Good. All right. Well, now we'll give you a different type of limit. Okay. Use the definition of derivative to find f prime of x. F of x is x squared minus x. Now you know what the derivative is. Okay, you can do that in your head. So you know what you're supposed to get for your answer. So let's see how you do. Okay. Now, do you want to do this with the definition of derivative? In the book, they refer to this as the simplified difference quotient. So if you're looking at one of the problems in the textbook, they call it the simplified difference quotient. I have no idea why. Well, I do, but we could call it the derivative. So what I want to do is the limit h goes to 0, f of x plus h minus f of x over h. And we know we have to end up with 2x minus 1 because we know what the derivative of x squared minus x is, right? Okay, so this will be the limit as h goes to 0 of x plus h squared minus x plus h minus x squared minus x over h. In answer to your question, no, you don't actually have to write limit at every step, but you need to write limit at the first step and the last step. You should demonstrate that you understand that you are simplifying the limit before you take the limit. Okay? So let's work on the numerator for a minute. That's x squared plus 2x h plus h squared minus x minus h minus x squared minus x over h. So you have x squared minus x squared. You have minus x minus minus x. So you can simplify this to 2xh plus h squared minus h over h. Remember what I told you guys earlier in the semester. You should have an h in every term. In every term, it should contain at least one h, so you can factor it out. So that becomes the limit when h goes to 0. H times 2x plus h minus 1 over h. And now, you can let h be 0. And you get 2x minus 1. Okay? All right, let's do another one of these. Make sure you get it. Get it. Move on to some other stuff. So again, we're going to need to do the limit as h goes to 0, etc. So limit h goes to 0 is 1 over x plus h plus 3 minus 1 over x plus 3 over h. So right now, if you plug in 0, you'll get 1 over x plus 3 minus 1 over x plus 3 is 0 over 0. So we have some work to do. So how will we simplify the top? Well, we can get a common denominator. Take the left-hand fraction and multiply it by x plus 3 over x plus 3. And take the right hand and multiply it by x plus h plus 3 over x plus h plus 3. In other words, this okay? So common denominator. You want to combine those into a single fraction. And now add the two fractions together since they have a common denominator. And you get x plus 3 minus x plus h plus 3 over x plus h plus 3 x plus 3 over h. Okay, you have x minus x. You have 3 minus 3. So this simplifies to the limit h goes to 0 of negative h over x plus h plus 3 times x plus 3, and you can move this h to there. Why can you do this? Because this is really, you can think of this as h over 1, so you flip and multiply. Now the h's cancel. Negative 1 over x plus h plus 3 times x plus 3. And now, when you plug in h equals 0, you get negative 1 on top. And x plus 3 times x plus 3, or negative 1 over x plus 3 squared. Which, now you can find the derivative of that with the chain rule, and you should get the same answer. Don't want to get ahead of ourselves. Okay, let's practice some more stuff. Let's take some derivatives. Each time you want to find the derivative. Okay, that's our first set. Okay. So these are all the very simple derivatives. The first one, just use the power rule. You get 12x squared minus 22x plus 6. Those, you should be able to do them as fast as I'm writing them. You should be able to just do them in your head. Okay, the second one, well, you could think of this as x to the half minus 2x to the third, if you're not good with the radicals. Remember, the derivative square root of x is just 1 over 2 root x. Or you could make it 1/2 x to the minus a half. Doesn't matter. And then this would be minus 2/3 x to the negative 2/3, which is the same as 1 over 2 root x minus 2 over 3 cubic root x squared. No, you do not need to do that if you don't want to. You should be able to do that, but you don't need to do that. Okay? Same here. You should be able to think of this either way. Derivative is minus 2 over x squared plus 10 over x cubed. Or you could do minus 2x to the negative 2 plus 10x to the negative 3. Either answer is acceptable. Okay, product rule. Get out the door here. Okay, first function times derivative of the second function plus the second function times derivative of the first function. And last, but certainly not least, quotient rule. Bottom function, low, d high times derivative of the top function, minus the top function, times derivative of the bottom function, over bottom function squared. How do we do so far? It's a good sign. Okay, Wednesday we'll do some more review. Friday we'll do some more review. I will put up in Blackboard at some point today a list of the various stages and problem numbers you guys can do in the book for practice. Okay? Good luck.